obviously reducing methane emissions is a good thing for both productivity but also for greenhouse gas issues. The science is still getting there in understanding exactly why certain amounts of methane are produced by different animals. What they know to this stage it certainly is influenced by age. And genetics does play a part, but exactly what the relationship is and how it works is still not completely understood. There has been some talk about trying to identify a gene marker for low emissions cattle, but that's still a long, long way off being reality. And certainly diet quality. As I said, methane is produced as a waste product, so higher diet quality, higher digestibility means lower methane emissions. So in terms of actually reducing methane emissions, obviously if we just didn't have any ruminants, we'd reduce the methane emissions. But if we did that in Australia, we would expect that that would just shift elsewhere, because I can't imagine Australians not ever wanting to eat steak again. So what we focus on in looking at these options is basically reducing the emissions intensity, so emissions per unit of beef produced, to avoid that leakage issue, and it's also much more realistic. Specifically in this work we've looked at the northern beef industry. Given that has about 3/4 of the total beef cattle for the country, the northern beef industry is defined as Queensland, the Northern Territory, and then the northern part of Western Australia. So it's a fairly major contributor to methane emissions, certainly in that way. The other reason we were looking at it was that it's much more extensive operations than some of those here in the south, and there's probably more room for improvement at lower costs, just given the margins for improvement there. So the options that we looked at was things like changing stocking rates, diet quality, and turn-off. And another one I'll mention just briefly is just improving reproduction efficiencies. And I'll mention briefly feed additives. So this graph comes from some data that was collected back in the collected as part of a stocking rate and pasture condition trial in central Queensland back in the 1990s. It was known as the Galloway Plains trial, and it was basically looking at 3 different stocking rates and 3 different pasture treatments. So if you look at there, it's a little bit, for people from the south, we talk about stocking rates, in the north the other way around. So we talk about hectares per animal. In the south they talk about animals per hectare. So you've got to flip your thinking around a little bit. But basically, as the stocking rate declines, so each animal has more space, then the methane emissions per kilo of beef are reduced, which basically is in line with the fact that we know that if animals have more space to eat themselves, they've got better live weight gains, better growth rates, so better performance all around. So this was just taking that data and converting it to methane measurements as well. The next thing, as I mentioned earlier, the methane emissions are a result of, it's a waste product from digestion, so higher quality diet means lower methane emissions per kilo of live weight gain. So this is based on a native pasture with 0.4 kilos daily, 0.4 of a kilo per day for each animal, and the improved pasture assumed to be 0.55 kilo growth rate per day. So you can just see how that gap exists. And also it's interesting, as animals get older and heavier, their maintenance requirements increase, so they need more feed to produce an extra kilo of live weight gain, and so that gap widens out as the animals get older. The next thing we looked at was improving reproduction efficiency, and this is something that extension staff and extension programs have been working on for many, many years. We've basically just taken some of that work and added this methane emissions element to it. So I used the breeding models that have been developed by the Beef CRC in breed cow dynama to look at if we change the weaning rates by 10% across the worst performing regions of the north, what that would do to weaning percentage, to methane intensity. So basically, by increasing the weaning rates, you're getting rid of cows that aren't producing a calf, so effectively are producing methane but not contributing to the productive capacity of the herd. So if you reduce the number of those, then it reduces the emissions intensity by about 11%. And as I mentioned, that focus of improving weaning rates has been a major research and extension effort for a long time. And the costs obviously vary, depending on where you are and what's required, but there's not one single thing that can change that overnight. It's a whole systems approach that needs to be put into play to actually achieve that. But if it does, then it can hopefully improve profitability as well as reducing emissions. Feedlot, again, this comes back to improved diet quality. So we developed just a daily time step model which gave the daily methane emissions against the daily live weight gain, and we did that for a pasture finished animal and compared to a feedlot finished animal. So basically, if we were feedlot finishing for 130 days, which is probably a little bit longer than a lot of cattle are fed for in Australia at the moment, but it's not too far out, it is reducing the methane emissions for that animal compared to if it had been finished on grass. Obviously, the cost of doing that depends significantly on the grain price, and we're trying to work out at the moment just how much excess capacity there is in feedlots in Australia. It's a bit hard to know because the published figures on feed and then the published capacity that feedlots are registered for, the gap between those two is not necessarily actual excess capacity. They might be registered for that much, but they don't actually have the pens for that area. So we're just trying to work out what that is at the moment. And then the issue then becomes what are the extra emissions from grain production, but it seems to be fairly minimal compared to the savings. So then the next option would be just turning animals off at a younger age. As I mentioned, that as animals get older and heavier, their maintenance requirements increase, so the amount of methane they're producing just to stay alive increases as against their actual growth rate. If we switch though to producing a smaller, younger animal at slaughter, we're going to need more of them, so a larger breeding herd, which has potential implications not just for management, but there's a cost there as well. And also, if that changed significantly the number that we were actually hoping to slaughter, that's going to have an impact at a meat processing level. The next slide just shows what that trade-off is between the emissions per kilo of beef and the emissions per animal. So if you look at the black line, which has got the little crosses on it, that's the emissions per kilo of beef. And the reason that it actually is higher for a lower kilo animal to be turned off is because of that extra breeding herd that's needed. It actually comes to a minimum at about 480 kilos turn-off weight, and then it increases slightly. You can't really see it on the scale of that graph, but the 480 kilos is about the minimum, which is much more in line with what's happening now. And you can then see that the emissions per animal, obviously as an animal gets older, it's produced more methane for its lifetime. Food additives and vaccines, they're fairly uncommercial at the moment. There's been a lot of work trying to work out if you feed cattle lipids or different supplements, what that does to their methane emissions, but at the moment it's pretty expensive actually administering it and ensuring that each animal gets it is pretty difficult. So we're saying it's still science fiction at this stage. So then, looking at the sequestration options for extensive grazing, and this is more where my PhD was basically focused. As I mentioned earlier, we could simply destock, which would reduce the enteric emissions, and there is some evidence to say that there would be a slight increase in carbon in the pasture and the litter on the ground, estimated about 0.3 tonnes per hectare per year over 100 years. But then we have the issue of fire and managing those rangelands that are no longer stocked and commercially viable. The soil carbon, it's not really known what the impact would be. We've got a biodiversity issue that if there is no one managing those rangelands, will feral animals and feral weeds become a problem? So there are all other issues that, if it were to happen, it would certainly require a lot more thinking about. The regrowth management is basically where we've been focusing a lot of our work. We've done some work looking at reduced regrowth clearing. So if we took the regrowth clearing that's happening in Queensland at the moment, and instead of people clearing entire paddocks, they were clearing just a strip. The paper that Peter Donaghy is the leader of, we found in that there was actually a negligible economic benefit in doing that in terms of production. And so in terms of the carbon sequestration, it was a fairly cheap way of increasing carbon storage in the landscape. And then using a modification of that model, we looked at increasing clearing cycles from 15 to 25 years. And that increases the average carbon stocks in the landscape by about 35% for brigalow and 42% for a eucalypt type land type. These are estimates only because the brigalow lands vary significantly, as do eucalypts, obviously, depending on rainfall and soil type and the actual vegetation mix that's there. But by doing that, by increasing the clearing cycle, the reduction in clearing costs was actually enough to make up for the slight reduction in production from those areas. So it was a negative cost. So in terms of carbon offsets for the northern beef industry, we've said that we need to focus on emissions intensity as well as the overall emissions to avoid that leakage problem that I mentioned. And many of the extension and research projects that have been going for many years in terms of productivity can also reduce emissions just through that better management. There might be some opportunities for additional offsets, but they're going to be limited by the capacity to do that. But also there is a possibility for some increased sequestration in terms of regrowth, particularly. So in terms of further research, we need a eureka moment, as Jill mentioned this morning, someone to provide us that really good function for sequestration rates on different land types and under different production systems. We've got some, we don't have enough accurate ones, but hopefully that will happen. And in line with that, then we need some better measurement systems to reduce the transaction costs of providing these offsets.
Thank you.